If you've ever bitten into a raw onion, you know exactly how aggressive it can be. Sharp, spicy, eye-watering. It's the kind of flavor that announces itself immediately. But then something strange happens when you cook it. That same onion, after a little time in a pan, turns mellow, rich, and sometimes surprisingly sweet, almost jammy. So what changed? Did the heat add sweetness? Or was the sweetness always there, hiding under the surface? Today we're breaking down, why do onions taste sweet when cooked? What's actually happening inside the onion? How heat transforms its chemistry? And why different cooking methods can make onions taste mildly sweet or deeply caramelized? This isn't kitchen magic. It's chemistry, biology, and a little bit of patience. Let's get into it, right here, on History of Simple Things. At first glance, an onion seems simple. It's just layers of pale flesh wrapped around each other. But chemically, an onion is anything but simple. Onions are mostly water, about 89%, but the remaining portion is packed with natural sugars, sulfur compounds, enzymes, and plant fibers. The key detail here is that onions already contain sugar before you cook them, mostly glucose, fructose, and sucrose. So if onions already have sugar, why don't they taste sweet when raw? Because that sweetness is being overshadowed. When you cut a raw onion, you're damaging its cells. That damage triggers a chemical reaction between enzymes and sulfur-containing compounds stored inside the onion. This reaction creates volatile sulfur gases, the same ones that make your eyes water and your nose sting. These sulfur compounds dominate your taste buds. They overwhelm your sense of sweetness and create that sharp, biting sensation we associate with raw onions. It's not that there's no sugar, it's that your brain can barely detect it under all that chemical aggression. In other words, raw onions aren't sugarless, they're just loud. Once you apply heat, the onion's entire internal system begins to shift. Cooking deactivates the enzymes responsible for producing those sharp sulfur compounds. Without those enzymes, the onion can no longer generate that intense raw bite. At the same time, heat causes the onion's cell walls to soften and collapse, releasing the sugars trapped inside. As the harsh flavors fade away, the natural sweetness finally has room to come forward. So the onion isn't becoming sweet out of nowhere. It's revealing sweetness that was already there. Another major factor is moisture. Raw onions are water-heavy. As you cook them, that water slowly evaporates. This concentrates everything that remains, especially sugars. Think of it like reducing a sauce. The less water there is, the more intense the flavor becomes. As onions cook down, their sugars become more concentrated, and your tongue perceives that as increased sweetness. This is why a fully cooked onion tastes richer and sweeter than a lightly sautéed one. Less water, more flavor, more sweetness. Many people assume caramelization is the main reason onions turn sweet, but that's only part of the story. Before true caramelization happens, onions undergo something called the Maillard reaction. This occurs when sugars react with amino acids at moderate heat, creating hundreds of new flavor compounds. These compounds add depth, savoriness, and complexity, not just sweetness. This is why cooked onions taste rich and savory, not like candy. The Maillard reaction creates that golden brown color, and those roasted, umami notes that make onions taste meaty or comforting. Sweetness is part of the transformation, but flavor complexity is the real star. Caramelization happens later and requires higher heat and more time. This is when sugars break down and reorganize into new compounds that taste distinctly sweet, nutty, and slightly bitter. True caramelized onions aren't just soft, they're deeply browned, sticky, and intensely flavorful. This process can take 30 to 60 minutes, and there are no shortcuts. If you rush it, you don't caramelize, you just brown. At this stage, onions taste sweet not because sugar was added, but because their natural sugars have been chemically transformed and concentrated. Not all cooked onions taste the same, and that's because cooking method matters. When you sauté onions quickly over high heat, you soften them and remove their bite, but you don't fully caramelize their sugars. The result is mild sweetness with a savory backbone. When you slowly cook onions over low heat, water evaporates gradually, sugars concentrate, and caramelization has time to occur. This produces deep sweetness and complex flavor. Boiling onions, on the other hand, removes sharpness, but also washes away some sugars into the water. That's why boiled onions taste mild but not especially sweet. Same onion, different outcome. Not all onions are created equal. Yellow onions have a balanced sugar-to-sulfur ratio, which makes them ideal for cooking. White onions are sharper and less sweet, while red onions contain slightly more sugar and often taste sweeter even when raw. Then there are sweet onions, like Vidalia or Walla Walla, which are bred to have lower sulfur content. With fewer sulfur compounds to overpower the sugars, these onions taste noticeably sweeter, especially when cooked. Less sulfur means sweetness shows up faster and stronger. Onions don't become sweet because something new is added. They become sweet because something is taken away, harsh sulfur compounds, and something else is allowed to shine. It's not magic, it's transformation. And the next time onions slowly melt into golden strands in your pan, you'll know you're not just cooking food. You're watching chemistry turn intensity into sweetness, one layer at a time. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.